Today our new topic is vector analysis. Okay, let's see what about the vector analysis. So in mathematics, we have learned about this set, right? So our set is actually a simple collection of number. Okay, a simple collection of number is called a set. But in case of set, order does not matter, right? So let's see here we have here this set whose elements are 1 to 3, right? And if we write 3 to 1, so that does not any effect to this set. Okay, so vector but in case of vector, order is matter. Okay, but in many real life situation, order is very important to represent a order information. So we use a concept which is called a vector. Okay, so vector is simply an ordered list of numbers written as like this: a1, a2, a3 up to n terms. So where each number is called a component of that vector. Okay, so a1, a2, a3 and each and every are the component of our vector, right? So here the order is matter. So vector can be written in two forms. So we can represent it a vector in a row, which is called a row vector, like this, and also we can represent it a vector along the column, which is called a column vector, right? So both forms represent the same vector actually. So one important type of vector is a null vector. When the all the components in a vector is become the zero, so there is no any magnitude, no effect. There is zero effect. So this is called a zero or null vector, right? Now let's see an example. Suppose a person buys three goods: rice 2 kg, wheat 3 kg and sugar 1 kg. So this can be written as a vector form. This, just take this number in a bracket. So this represents actually a vector. Okay, so 2 3 1. So here order matters because here the 2 is indicate the weight of rice and 3 is indicate weight of wheat and 1 is indicate the weight of sugar. And if we change any number or interchange, then the meaning uh, changes. Okay, so now let's see the vector addition and the scalar multiplication of vector. So adding the two vectors means just add their corresponding elements. So here we have a vector A whose element a1, a2 up to an, and another vector V whose element is b1, b2 dot dot bn. Okay, so then the a plus v, the addition of these two vector will be just add the element, corresponding elements. So here a1 plus b1 and then next a2 plus v2 and dot dot up to an plus vn, right? And for subtraction, the rules will be same. So just minus the corresponding element. So here a1 minus v2, I sorry, a1 minus b1 and a2 minus b2 and up to an minus bn, right? And now for the scalar multiplication, if we have uh, assume a vector A is representing a vector whose components are this a1, a2 up to an. So if we multiply with this vector by a lambda, lambda is a number or a scalar. So then then the vector will be this, like this. If we multiply lambda with vector A, then the component will also multiplied by the lambda times. Okay, now let's see an example regarding this. So here we have a vector A and the vector V whose vector A's elements components are 1 3 and minus 2, and for the vector V the components are 4 0 and 6. So then the adding the two vector A plus B will be just add the corresponding uh, components from our vector. So here A plus B will be at the first 1 plus 4 comma, then 3 plus 0 comma, then minus 2 plus 6, which give us this vector. And for the subtraction, so the rules is same. So just subtract the corresponding element of our from our vectors. So 1 minus 4 comma 3 minus 0 comma and minus 2 minus 6, we have this vector. And for a scalar multiplication, just take a 3, which is a number, so it's denoted as scalar actually. So if we multiply 3 with vector a, then the all the components is multiplied with by the 3, right? So let's now learn how the vectors are used to calculate a total cost in economic science, right? So here we use two vectors, a quantity vector and a price vector. Okay, a quantity vector and a price vector. Suppose a person is buys three goods: rice and wheat, sugar. Rice with 2 kg, and wheat 3 kg, and sugar 1 kg. So here we can represent the quantity vector by the q as follow here, the 2 3 1. Okay, and the prices are, for the rice the price is rupees 40, and for the wheat price is rupees 30, and for the sugar price is rupees 50. So price vector we can represent it by p equals to, just put here the all the component 40 comma 30 comma 50. Okay, so the total cost, so for the total cost, just multiplying the corresponding values from quantity vector and the price vector and add them, we have here the for the first goods, we have here the 2 kg rice and 40 rupees 40. So here just multiply with 40 plus 3 times 30 and plus 1 times 50, we have this rupees 220. So this method is called actually a scalar or dot product of the two vectors, and this scalar product is also called inner product, right? So let's see what about the inner product. So for a pair of vectors A is this, okay, and for vector V we define their scalar product with this bracket. Just multiply the corresponding elements from our two vectors. So a1 b1, okay, and plus a2 b2 plus a dot dot up to n bn, okay, and we can denote this by the summation 1 to n ai bi, okay. So this scalar product is also called inner product actually. So for finding the norm of a vector, let us consider a given vector. Here we have this vector and find out the inner product of this original vector with itself. Then the inner product will be in this bracket. We can represent the inner product of a vector, which is equal to just square of the all the components and add them, which give us the inner product. So the inner product of vector a will be a1 square plus a2 square plus dot dot a n square, and the positive square root of this inner product of a vector with itself is called a norm or length of that vector. So let's see here, for the vector x, this is the components of the vector x, is denoted by a small l of x. Okay, so here if our question was this, the find the norm of the following vector. So for the uh, first vector whose two components 2 and 5, so then the inner product will be, then what will be here, then the inner product will be this, the square the components and add them, 2 square plus 5 square, we have 29, and thus the length of the vector will be root over 29, right? Just here the inner product of that vector to the power 1 by 2, to the power 1 by 2 means the root over that values, that number. Okay, and our next question is the find the inner product of the following of vectors. So here we have two vectors, 1 and the 2. So for the first, let the vector here a and v. So the inner product will be just multiply the corresponding element 2 with 4 plus 3 with 5 plus 4 with 5. Okay, so we have 43. And for the vector, for our second question, here we have vector, just let the vector a is representing this and vector b is representing this, then the inner product of this vector ab will be just multiply the corresponding element minus 2 multiply with 4 plus 3 with 5 minus 3 with 5 plus and 4 with minus 6, we have minus 47. Okay, so when the two vectors are said to be orthogonal to each other if their inner product is 0. Okay, when a v is become 0, then the vectors ab is said to be orthogonal to each other. Okay, so do not forget like and subscribe my channel. Thank you.